December 7, 1941, as battleships smolder in Pearl Harbor, a quieter disaster unfolds across the Pacific, tents sag under monsoon rain, canvas rots in weeks, and by the third sunrise after the attack, the War Department's briefings are less about enemy movements and more about pneumonia, mud, and ruined ammunition that never met a Japanese bomb. From the Philippines to Wake Island, men fall asleep on cots beneath fabric that dissolves under tropical downpours, waking to boots filled with rainwater and blankets gone sour with fungus by morning, a small indignity that becomes a strategic crisis when entire depots flood and crates of munitions swell, warp, and fail. Wooden barracks, the natural fallback, are a fantasy on coral atolls where there is no forest to fell, no carpenters to spare, and no weeks to waste. The Navy's projections are damning, 18 months to build what must exist in weeks, while the war accelerates like a typhoon tightening its eye. In Washington, maps curl under desk lamps as Brigadier General Eugene Raybould stands over a table of weather charts, shipping timetables, and construction schedules, realizing the front line includes the sky and the ground and the air inside a soldier's lungs, not just the coordinates where shells fall. The equation before his engineers is brutal in its simplicity: produce a shelter that can be stamped out in Pennsylvania, ride a railcar to a West Coast pier, cross 10,000 miles of submarine-infested water, land under threat of bombing, and go up in a single day under hands that may never have held a wrench, then stand its ground against typhoon winds, monsoon torrents, jungle rot, and salt air that eats metal like acid. Heat spikes to 130 degrees on airstrips scraped from volcanic sand, rain can dump 15 inches in 6 hours, and every new foothold is a strip of shoreline and scrub where the weather is as relentless as any enemy patrol. The ledger is equally unsparing. A standard army tent costs $12 and lasts about a month in the jungle, while a wooden barracks runs $8,000 and demands 6 weeks of skilled labor, neither option compatible with island-hopping campaigns that need 50,000 men under roofs yesterday. Letters home describe the same refrain: boots filling with rain at 0300, cots sinking into mud, and a night sky that leaks through tarps as if the stars themselves were holes, while medical officers file reports showing respiratory infections hospitalizing more men than enemy action in some sectors. It is not a story about comfort, it is a story about force preservation, because a unit that coughs itself sick in the dark cannot repair aircraft at dawn or hold a perimeter at noon or march inland by dusk. On the coral and the lava and the mangrove flats, the geometry of survival becomes a design brief: deflect the wind, shed the rain, vent the heat, resist the fungus, deny the termites, and do it all with parts light enough for 4 exhausted men to lift without machinery or masonry beneath their feet. The number of humans to be housed spirals upward with every convoy: air crews, mechanics, radio operators, medics, cooks, engineers, and the old math collapses, because conventional construction cannot keep pace without surrendering the initiative to weather, distance, and time. Raybould circle sketches and erases and sketches again: no poured concrete, no embedded wood, no finicky fasteners that seize and rust, no bespoke dimensions that won't fit a railcar, nothing that demands a trained carpenter when what arrives on the beach are riflemen, sailors, and Seabees whose expertise is courage under pressure. The brief hardens into a dare: a building lighter than a jeep, flat-packed to ride a single railcar, assembled in one day with basic tools, costing under $1,000, and hardy enough to shrug at the same conditions that reduce permanent buildings to rubble or mold. And then the timeline lands with a thud: 10,000 units ready to ship in 6 months, because logistics is a theater of war with its own battles, and shelter has suddenly become ammunition for endurance. Across the country, telephones summon steel men, factory foremen, structural engineers, and field officers, while university labs and navy yards dust off ideas once dismissed as eccentric or unbuildable, because eccentricity becomes common sense when the nation needs a city's worth of roofs every month. Reports from the Pacific read like cautionary psalms: canvas tents shredding in minutes under squalls, timber platforms collapsing into groundwater, ridgepoles chewed hollow by insects in a season, and interior air turning to wet heat so dense that men wiped down their rifles as if they were sweating. On islands where the surf never sleeps and the barometer lies, the landscape punishes mistakes, and every day a shelter fails is a day when engines won't start, radios won't transmit, and morale frays like rope in salt spray. To make anything work here, the building itself must become its own structure rather than a collection of vulnerable parts, and the air inside must move as surely as the wind outside, or else the ceiling will rain each night with condensation that undoes a day's rest. The United States has the factories and the steel and the railways and the ships, but materials alone are not an answer. They are a weight unless shaped by a design that respects the tyranny of distance and the indifference of weather. So the call goes out, not for a drawing to be tendered in 3 months, but for a prototype to be raised in days, tested in storms, and scripted for assembly by crews who will arrive sleepless, under fire, and expected to turn chaos into a camp by nightfall. Every constraint is an instruction. No floor by default if the floor is the slowest thing to build and the first to rot, no wood where the earth can reach it, and no joint that can't be tightened or replaced by a tired hand with a basic wrench. Every mile between factory and foxhole is a reason to number the parts, nest the panels, standardize the bolts, and make the instructions so visual that a language barrier or a midnight landing doesn't turn a kit into scrap. What the engineers must build is not a building but a system, a grammar of panels, fasteners, and curves, so simple that it compresses expertise into a choreography any 6 people can learn by doing once. The storm calendar waits for no one, monsoons in one theater, nor'easters in another, typhoons stalking shipping lanes, and meanwhile submarines prowl beneath the cargo that must deliver roofs before fatigue delivers defeat. There is a paradox at the heart of the order: something light must be strong, something fast must be durable, something standardized must be flexible, and all of it must be cheap enough to multiply across hundreds of islands without starving other fronts. Men in muddy boots will test the truth of every promise. Does the door stick after the first rain? Do the bolts seize after the first spray? Does the interior air move at all at noon? And when the wind comes like a fist, does the structure bend and return or bend and break? Under the urgency, a deeper motive takes hold. Shelter is dignity as much as defense, the difference between sleep and a sleeplessness that dulls every edge a fighting force needs, and it is this human calculus that transforms specifications into a mission. February 1942 arrives with the thunder of railcars and the smell of oil and steel, and somewhere in Rhode Island a warehouse floor clears to make room for an idea that will have to outrun the weather, the ocean, and the calendar. No committee will save them, no marble office will draft what the wind must approve. Only iteration, metal, and nerve will, if they are lucky, turn a drawing into a geometry of survival before the next season makes more orphans of plans that looked clean on paper. In that warehouse, the design brief condenses to a sentence: build something that can arrive in pieces and become, by evening, a dry room where men can sleep and wake as soldiers again. The nation has sent its factories, its rails, its ships, and now its faith in engineers who must stitch a roof from arithmetic and corrugations and the humility to learn from failure at the speed of war. And as the first pallets of corrugated panels clatter onto a loading dock, the challenge crystallizes into destiny: build the impossible in months, not years, or watch the climate do what the enemy alone could not. The British had already faced a version of this problem and improvised an answer: the Nissen Hut, a semi-cylindrical corrugated iron shelter invented by Major Peter Norman Nissen in 1916, a form so efficient it could be packed tightly, erected quickly, and multiplied across fronts from Flanders to North Africa. By the late 1930s, production revived and variants housed troops, mess halls, and depots, proof that the arch could trade ornament for speed, shedding wind and rain with indifferent grace while saving scarce materials and shipping space. But what worked on concrete pads in temperate Britain and dry North Africa threatened to fail in the Pacific's wet furnace. The British pattern used heavy steel components that demanded machinery to lift, relied on timber frames that fed termites, and assumed a prepared foundation, everything the islands refused to provide. Ventilation that felt adequate in a Scottish drizzle became a curse at Guadalcanal, where small windows trapped steam and turned interiors into metal cookers by noon, a detail that read like a footnote on a drawing but lived like a slow punishment for lungs and morale. The Bureau of Yards and Docks spread the British drawings across a table, and Commander John Philip Drosfeld traced the genius with one finger, the arch geometry, and the liabilities with a pencil: mass, foundation bolts, wood-to-ground contact, and ventilation designed for another climate and another war. The calculation was no longer abstract. Every pound lifted in Rhode Island meant a pound craned at dusk under the threat of shelling, Every bolt drilled into concrete meant a delay that rain or artillery could turn into loss, and every wooden rib was a future meal for insects that never sleep. Meanwhile, a heretical voice, long dismissed, got louder in the way that necessity makes eccentrics into prophets. Buckminster Fuller had argued for years that houses should be built like machines, lightweight, factory-made, shipped flat, assembled fast, a Dymaxion logic that suddenly sounded less like a manifesto and more like a memo. No one stamped an official requisition for Fuller's services, but the ethos slipped through journals and lectures into the engineering bloodstream: treat a building as a product, solve for transport before aesthetics, and let materials science dictate form rather than habit. The Navy chose a place and a name that would define the object: Quonset Point, Rhode Island, an air station by Narragansett Bay where rail met water and workshops could turn drawings into metal before the ink dried. The choice was tactical and cultural. Rhode Island's industry knew sheet metal the way a farmer knows soil, with mills to the west, shipyards to the south, and a workforce that could be taught a new rhythm if the beat was clear and the stakes were explained without euphemism. In March 1942, a coalition assembled that felt less like a committee and more like a raid: Strand Steel specialists in prefabricated farm buildings, George Fuller Company's rapid assembly architects, and Navy officers fresh from islands where typhoons and salt spray had already conducted their own experiments in failure. Otto Brandenburger took the brief and flipped it: if the wooden skeleton is what rots and slows us, then remove the skeleton, let the corrugated steel skin carry the load, an arch self-braced by its own curve, a barn logic recast for war. This violated the categories many trusted: steel was for frames, not for shells, but the Midwest had already taught a quiet counter-lesson in fields where arched metal barns shrugged off tornadoes without a timber rib inside. The British reports from Burma and Singapore arrived like pathology slides: fungus devouring paints and preservatives in months, fasteners eaten to failure by humidity, and beams reduced to hollow shells by insects. Each horror story became a design constraint, an instruction to remove vulnerabilities rather than hope to outlast them. From those constraints emerged a doctrine: no wood in contact with ground, hot dip galvanize every steel surface, specify aggressive ventilation to prevent night rain from condensing inside, and ensure each fastener could be replaced without dismantling the whole. The team's synthesis was simple to say and costly to achieve: take the Nissen arch that laughs at wind, strip weight until 4 people can lift a panel, erase the need for concrete or carpenters, and reimagine the interior climate as a flow problem solved by louvers and ridge vents, not by hope. Where Nissen huts once relied on frames that needed carpentry, the Quonset would arrive as a kit of numbered metal ribs or self-supporting skins, standardized bolts, and end walls that could be assembled like a language learned on the beach at dawn. Fuller's shadow hovered over every decision even without his signature on the drawings: design the supply chain first, then the structure, pack parts like nesting bowls, demand that assembly be a choreography for unskilled hands, not a ritual for tradesmen with time. Quonset Point supplied the final ingredient, a manufacturing tempo that could keep pace with the appetite of a global war, because an elegant shelter that cannot be stamped by the thousand is only a prototype, and prototypes do not sleep mechanics or shelter radios in the rain. The pivot was complete by April: borrow the arch, abandon the weight, ventilate the heat, galvanize against the ocean, and pull the foundation out from under the design so the earth itself, sand, coral, dirt, became a serviceable floor by default. Nothing about this was romantic. It was arithmetic weaponized by empathy, the understanding that a dry night is a force multiplier, that air which moves is a kindness as well as an engineering solution, and that the best building is the one that exists in time to matter. So the team wrote a new gospel in steel: a hut that behaves like a bridge when the wind hits, like a tent when it anchors, like a ship when it resists rust, and like a product when it ships, factory to rail to pier to beach to bolt, each step anticipated in the first pencil line. If the Nissen hut taught the world that a curve could be a roof and a wall at once, the Quonset would teach that a curve, properly fabricated, could also be logistics, climate control, and survival condensed into a kit that respects the limits of men already at their limits. What began as imitation had become divergence: the same silhouette, but a different soul, tuned to humidity rather than dust, to rot rather than cold, to assembly by the exhausted rather than the trained, an American answer to a British invention, shaped by a theater where weather is an enemy with perfect attendance. The order that closed the meeting that day could have doubled as an epitaph if they failed: keep the arch, lose the foundation, add the air, ban the wood, and ship it by the hundreds before the next storm reminds everyone what time costs in a war measured as much in nights endured as in miles advanced. They gathered in Rhode Island with the urgency of people who knew that the weather did not negotiate, called to Quonset Point Naval Air Station where rail met water and a warehouse floor could be cleared to become a laboratory under lamps that burned late into every night. The Navy offered 2 instructions that were less a brief than a verdict from physics: the new huts must be arch-shaped, to deflect wind and fragments, and they must be fast and simple enough to assemble at speed by untrained hands. The second instruction hid the first cost: simplicity is expensive to design, and the third demand followed immediately: deliver within 60 days, because storms were already on the calendar and men were already in the field. Otto Brandenburger, the only licensed architect on the Fuller Company team, took the chair not because of rank but because he understood soldiers and schedules, having worn a uniform and reviewed plans that had to work the first time. Around him, engineers and builders from Georgia. Fuller Company brought the muscle memory of rapid construction, while Navy officers fresh from the Pacific translated field failures into specifications that could not be ignored without costing lives. On the table lay the British Nissen Hut drawings, useful as a compass, dangerous as a map, because the arch solved wind and material scarcity, but the weight, the floor assumptions, and the timid ventilation belonged to a different climate and a different war. Brandenburger's team began by stripping the problem to essentials: what must the geometry do, what must the skin resist, how must the air move, and how could any 6 exhausted people raise a roof before dusk with little more than wrenches and nerve? The first doctrine was as plain as a scar: remove wood wherever the earth could touch it, because termites and fungus do not negotiate, and every piece that rots is a future repair in a place where repair time is an enemy. The second doctrine insisted that the building breathe like a lung, not a box, with ridge vents and end louvers that turned night condensation from an inevitability into a controllable variable. The third doctrine said the structure must carry itself, not hang upon a skeleton that added labor and invited failure, which led to the most radical move of all: make the corrugated steel skin do the work, a shell that is also a beam, a curve that needs no ribs at every step. The fourth doctrine faced the logistics head-on: hot dip galvanize every steel surface and standardize every fastener so salt air would not eat the hut alive and every bolt could be replaced in minutes by hands that had never studied a blueprint. A fifth followed naturally: design the kit like a sentence in a language that could be learned on the beach, parts numbered, steps illustrated, tolerances generous enough to forgive a rough landing and a rougher crew. Names gathered on the roster: Robert McDonnell, Tomasino Secondino, Dominic Ergo, colleagues who turned field notes into shop drawings while Brandenburger translated urgency into decisions, because every hour spent thinking in the warehouse saved nights of misery in the islands. They accepted the Nissen Hut's gift, the arch, and rejected its liabilities by calculation, promising a shelter that weighed less, shipped flatter, assembled faster, and breathed deeper, tuned for humidity and salt, not drizzle and dust. The 60-day clock was not a motivational poster but a metronome that governed everything, turning the warehouse into a place where failure was a teacher every afternoon and every evening a new attempt to be proven by morning wind and water. They mocked up end walls with interchangeable panels, screened for heat and solid for cold, because the ocean did not only bring storms but also climates that shifted with every new anchorage, and the hut had to be fluent in all of them. They argued about floors and then dared the most unromantic solution: do not mandate one, because wood on the ground is a promise made to termites, and time spent building a floor is time not spent building a roof where men can sleep now. If a floor was necessary, they would raise it on a light metal framework and plywood, insulated and lined with masonite where conditions demanded, but the default would be speed, roof first, always. They standardized the curves so panels could be nested for shipping and lifted by 4 people without a crane, a dimension born from railcar widths, ship holds, and human backs, not from any aesthetic ambition. Fasteners became a philosophy: common sizes, corrosion-resistant where possible, accessible from inside and out, replaceable without dismantling half the building, so maintenance became an act of minutes rather than a saga of days. Ventilation was not an afterthought tucked into a corner of a drawing, but the spine of the design, because every Pacific report insisted that a hut that did not move air became a sickness machine by noon and a rain cloud by midnight. At Quonset Point, the choreography of manufacture began to mirror the choreography of assembly, parts that nested in crates in the exact order they would be needed on the ground, so the kit unpacked into a story the crew could follow with tired eyes. They imagined the first hour on a hostile beach, bolts spilled in sand, instructions soaked in spray, and wrote resilience into the process with spare hardware, duplicated diagrams, and tolerances that forgave clumsy gloves and shaking hands. Every evening brought a small trial, a hose to mimic rain, fans to push wind against the curve, heaters to force the interior to sweat, and then a tally of drips that became changes to flanges, seams, and vents by dawn. Galvanizing baths were booked before the final drawings were blessed, because steel unarmored in salt air is a promise already broken, and the war would not wait for perfect. They did not lie to themselves about the strain. Simplicity on the battlefield is complexity in the factory, and the hut would only be simple if every complication had been faced in advance and turned into a repeatable step. Meanwhile, the Navy confirmed what the shop floor already knew: Fuller could not carry the whole load if the design proved out, and production would soon be shared and then dominated by Strand Steel, the Detroit division that could stamp and ship at the scale the war demanded. Strand Steel brought an innovation that fit the doctrine like a glove: grooved, spot-welded ribs that accepted nails for the corrugated skin and masonite liner, cutting assembly time by eliminating much of the nut and bolt ritual that exhausted crews. In the quiet between hammer blows, Brandenburger kept returning to the first principles taped to the wall: keep the arch, lose the unnecessary weight, make air move, galvanize the skin, standardize the parts, and remember always who is waiting for this to work. The British drawing stayed within reach not as scripture but as ancestry, a reminder that good ideas come with conditions and that survival in Burma and North Africa did not predict survival on coral and jungle. Every complaint from the field became a line item on the checklist: leaks at the ridge, sweat on the ceiling, doors binding after rain, fasteners that seized, foundations that settled, and for each, a countermeasure that could be shipped in the same crate as the problem. If the hut could act like a bridge by distributing loads along its curve, like a tent by anchoring without concrete, and like a product by arriving as a complete sentence, then perhaps it could also act like mercy in a place that offered little. The 60-day mark stopped being a deadline and became a promise to people who did not know the engineers' names and did not need to, so long as the curve kept the rain out and the night air moved enough to let a human chest rise easy. On paper, the deliverable was a building system. In practice, it was a way to convert fear and distance into bolts and panels and a rhythm any six can learn, because survival scales only when understanding does. They were close enough now to imagine the first crate opened on sand, the first arch lifted, the first louver turned to catch a hot wind, and the first quiet inside after weeks of rain that felt like an enemy with perfect aim. The order that closed the meeting did not need embellishment: fit the last changes, book the first shipments, and be ready to prove, not argue, because the Pacific would grade their work without kindness and without delay. 60 days to turn a British arch into an American system, 60 days to teach steel to breathe, 60 days to make a roof that behaves like a verb, and then the verdict of weather, salt, and war. They turned the warehouse floor into a factory and a wind tunnel at once, chalking arcs on concrete, stacking corrugated panels like cards, and learning with each hour how to translate the Navy's two-line brief into a body that could live and breathe under war. Every piece had to justify its weight and its place in the crate, because what could not be nested on a rail car and rolled onto a ship in perfect order had no business arriving on a beach where daylight and calm were rationed. The clock was merciless but clarifying: 10 people, 1 day, only hand tools, a promise that turned design into choreography and eliminated anything that required sparks, sagas, or specialists. Dimensions stopped being aesthetic and became logistics, a grammar of widths and lengths that matched railcars, ship holds, and human backs, so a single kit could become a room by dusk without a crane touching it. They fixed the first profile around the human body and the railcar, a semicircle with an 8-foot radius in the original 16 by 36-foot frame, a geometry that offered headroom without waste and enough curve to shrug at wind like a hill. The field demanded more space as orders swelled, so the standard grew to 20 by 48 feet, 960 square feet of floor that could serve as barracks, clinic, mess, or radio room, without changing the DNA of speed and simplicity. Where ports demanded scale, a utility model stretched to 40 by 100 feet, a hangar for supply and maintenance that kept the same logic, arch, corrugation, kit, and crews who could follow instructions more easily than they could find a carpenter. With sizes locked, the daily work turned to sequence, end walls first to tame the wind, ribs or arch panels next to find the curve, skins to close the weather, and doors and louvers last to make the interior a place for lungs and tools. Failure taught the fastest, so each evening the crew hosed the seam lines, aimed fans at the arcs, and heated the interior to force sweat from the ceiling, counting drips and drafts as if they were bullets to be avoided by the next revision. The breakthrough was not glamorous. Parts were numbered in the order of use, crates packed so the first lid revealed the first step, and every bag of bolts doubled as insurance against a spill in sand where perfect counts went to die. Ribs spaced on 4-foot rhythms and corrugated skins laid in continuous arches made the hut behave like a single muscle, distributing load so that gusts became a test of curvature, not a series of weak points. Galvanized corrugated steel turned the ocean's appetite into a slow complaint instead of an immediate victory, buying months and years in climates where unarmored metal failed as quickly as promises. They tried liners and insulation not as luxuries but as weapons against humidity, discovering how a pressed-wood lining and fiber could quiet heat and noise enough to let a night do its work of repair. Ventilation migrated from the margins of the drawing to the center of the plan, ridge vents to drain heat, end louvers to coax flow, and clear paths that kept air moving even when the outside felt like a wet furnace. The floor became a referendum on reality, where doctrine once insisted on tonyan groove plywood over a light frame, experience replied that a roof today and irreparable ground tomorrow was often the wiser bet. So they changed the sequence and the default, making the roof the first mercy and the floor a kit option rather than a mandate, cutting shipping weight and assembly time exactly where the beach demanded it most. The rule that followed was human: anything 4 people couldn't lift wasn't allowed, and anything that required a second try to understand had to be redrawn or renumbered until sweat and fatigue could not confuse it. To keep hands honest, the team rehearsed assembly with new crews under a clock, then rewrote diagrams again and again until a single glance matched a single action even in rain. The manuals that grew from this discipline read like field sermons, pictures more than paragraphs, cautions about anchoring and sequence, and variations for tropical, northern, and utility designs, because climate is a language. Anchoring without concrete remained a hard problem with a simple answer: behave like a tent scaled to steel, using stakes, cables, and sleepers so the building flexed with the ground rather than tore from it. When a storm hit the test yard with a nor'easter spite, the shells bent and returned instead of buckling, proving what the arch had always promised: strength through curve, not through mass. The first model, 16 by 36 with an 8-foot radius, stood as proof of concept, but the 20 by 48 standard became the workhorse the war needed, balancing ship space, interior volume, and crew effort with uncanny economy. At larger scales, the 40 by 100 utility buildings took the same kit logic and amplified it, using the arch to span light and clear, a geometry as suitable for crates and engines as for cots and bunks. Strand steel's rise into production brought lighter frames, flatter shipped panels, and cost savings that multiplied the design's reach, shifting manufacturing from a heroic sprint to a sustainable cadence. What had begun as a sketch on a crisis table became a triad: the T-rib berth, the redesign with vertical sidewalls for efficiency, and the strand steel refinement that pushed weight down and numbers up. Even the way edges met changed with the tempo: factory curved pieces reserved for the ridge and horizontals shipped flat for the rest, a small shipping miracle repeated thousands of times without fanfare. Everyone learned to respect the tyranny of sequence: misplace one box in a crate and an hour vanished on a beach, mislabel one panel and a crew stood staring at metal that would not speak. What saved them was the insistence that the kit teach itself, that the order of appearance matched the order of need, and that no step required knowledge not already earned by the last. On paper the huts were steel and masonite and bolts, but in the yard they were verbs: lift, align, fasten, brace, vent, performed by people too tired to admire the elegance they were proving. The rhythm they found: end walls, arches, skins, closures, anchors, was a song teams could hum without looking, a pattern that turned strangers into a crew within an hour. Inside, the pressed wood lining did double service, softening noise and shielding skin from metal that would otherwise burn in the sun and chill at night, a comfort that doubled as a preventive for illness. Outside, the galvanized corrugations broke wind into harmless eddies, a texture that looked humble and sounded like rain when storms came, a sound that some would remember decades later as safety. When arguments flared about adding features, extra windows, better doors, the clock and the crate settled them, because war tolerated only what shipped and built at speed. What engineers call tolerance the crews experienced as forgiveness, the small mercies that let a misaligned hole or a bent flange still find a home without calling for a machine that was not there. The 20x48 became a default not because someone decreed it but because it kept winning the only contests that mattered: how fast to shade, how little to ship, how much to fit inside without waste. By the time the first production runs left the docks, the hut was no longer an experiment but a species, adapted for tropical, northern, and utility habitats, each a variation on the same survivable curve. Reports coming back from early deployments praised speed first: 10 men, 1 day, hand tools, then breathability and dryness, and only then the quiet grace of a space that could be anything today and something else tomorrow. In the yard the final lesson was learned 100 times: the secret of strength here was not thickness but shape, not heroics but repetition, not genius but listening to failure faster than failure could spread. When the last pallets slid into place for shipment, they carried more than steel, they carried a script any crew could perform and an answer to a question the weather kept asking. The plan to drop the floor from the default had done what it was meant to do: have the fiddly work on bad ground and put the first dry air above a cot while the earth caught up later with whatever boards a site could spare. And in that sequence was a philosophy the men understood without a lecture: roof first, breath first, then comfort as the day allowed, because a rested mechanic and a dry radio were worth more than a perfect finish. What rolled onto the pier was a new American sentence written in steel: 16x36 when small is swift, 20x48 when balance is king, 40x100 when the job is supply, and the same curve holding all of it together. The curve did not argue when the wind rose or the rain fell, it simply translated weather into force and force into ground, asking only that the anchors held and the crew followed the order they had practiced. By then, even the skeptics had to admit that the best kind of engineering looks inevitable in hindsight, and that inevitability is bought with nights of iteration and days of restraint. They were ready now not just to ship huts, but to ship a way of building under fire that other theaters and other wars would inherit, a discipline disguised as a kit. And as the cranes swung the crates toward Liberty ships, the men on the dock could imagine what the first crew on the first beach would do by evening: raise a curve against the weather and find, under it, a little civilization. They did not wait for a battlefield to teach what a winter could teach in a week, so the first huts faced New England squalls that hurled sleet sideways and bent trees like bows, and when the wind slammed the arches they flexed and returned, proving that a curve could turn an insult into a shiver instead of a break. In those cold rehearsals the geometry wrote its first oath: distribute force along the skin, let the corrugations act like ribs, and never let a single joint carry more than its share, because resilience here was a choreography of many small strengths rather than one heroic member. Then came heat and water, the cruel allies that turn a strong room into a swamp, and the lesson was immediate and visible: the ceiling sweated by midnight until the inside rained on sleeping men, a physics problem solved not by denial but by air, by creating a path for heat to escape before it met steel and surrendered as droplets. Ridge vents widened and end louvers grew bolder, no longer polite apertures but lungs for the building, encouraging cross-ventilation that pulled fresh air low and expelled warm damp air high, an old principle rendered urgent by a climate that punished hesitation. What a drawing calls condensation the body calls fatigue and infection, and so ventilation climbed from a footnote to a headline, the thing without which no other virtue mattered, a priority embedded in manuals that taught crews how to make air flow even when the weather felt like steam. The inside surfaces learned to help, too. Liners that trapped a bit of heat at night and softened the drumbeat of rain also kept moist air from finding cold metal, shrinking the nightly rainfall to a memory instead of a ritual. Every storm taught something different, and anchoring taught the cruelest truths the fastest, because a hut unmoored is a promise broken, no matter how perfect its curve, and the solution was not concrete that islands could not spare but the scaled logic of a great tent held to earth. So the kit embraced stakes, guy cables, and sleepers, creating a triangulated grip between steel and ground that let the structure move a little without losing itself, a dance with the soil rather than a duel with it. In places where the wind learned the names of buildings, crews added sandbags like skirts and heaped earth against the sidewalls, a practice borrowed from northern outposts where Marines had tied tin roofs with wire and learned to trust friction and mass as much as any bolt. The manuals did not moralize, they measured and instructed, insisting that anchor points be regular, cables be tensioned, and stakes bite soil deep enough to matter, because nothing fails so fast as an almost correct tie-down in a night of gusts. Tests of anchoring methods proceeded under haste and skepticism. Some sites used timber sleepers drilled for bolts, others married base plates to soil with long spikes and cross-bracing cables, and in each case the standard emerged: redundancy beats elegance under wind. When a nor'easter arrived with its rude education, huts with complete anchoring lists survived with bent edges and rattling louvers, while those with shortcuts turned into teachable moments, their arcs intact but their feet scuffed out of the sand, a humiliation that rewrote checklists by dawn. Crews learned to treat soil like a variable and torque like a language, driving stakes where loam would grip and opting for deeper pins where sand needed length instead of girth, a wisdom that became pictures in the manuals so the lesson arrived with the crate. Inside, the air finally moved with intention, louvers breathing at the ends, ridge vents sipping convection like a constant, and baffles shielding openings from driven rain while still letting the hut exhale, a balance that sounds delicate until one sees how forgiving it is in practice. The corrugated skin, galvanized and stubborn, wore its first scars with dignity, surface rust at edges where hands had rushed or tools had slipped, easily caught and sealed by crews who now carried coatings as part of the ritual, another small habit that added months to a lifespan. Field modifications came home the way rumors do and turned into doctrine, a 4-foot roof overhang to keep rain from hammering end walls, louvers shielded with hoods, and in the hottest stations, partial openings along the sidewalls that made shade behave like wind. Nowhere did the decision to drop the default floor pay off more than in deployment tempo, because the gift of a dry roof in a day was worth more than a perfect floor in a week, and crews could always raise planks later on sleepers once the first night's rest had returned humanity to tired eyes. A hut is only as good as its first hour under stress, and in New England the first hours featured sleet and predictable malice, while in the tropics the first hours featured the heavy stillness that precedes downpour, each theater confirming that a single kit could carry both stories if it breathed and held its ground. Every whispered complaint received an answer in steel or sequence. Bolts that seized became bolts of a standard size with protective coatings, doors that swelled gained clearances and better frames, and seams that wept gained gaskets and tighter laps where the wind habitually pried. What looked like small edits added up to a different creature by the end of the month, no longer a prototype in courage but a product in truth, with the humility to admit that weather writes the last draft and good engineers write in pencil. Critics asked whether an arch alone could stand up to the ferocity of island storms, and the early data was plain: what fails first is not the idea but the anchoring, which is to say that the sea does not despise curves so much as it despises carelessness. The manuals became sterner on that point, adding diagrams that showed how wind finds a hut and how ground must answer back, making visible the invisible forces that break things so that a crew could outwit them with ropes and stakes and angles. At the same time, ventilation sections thickened with cautions drawn from barracks medicine, reminding builders that foul air and damp bedding incapacitate a unit more efficiently than any sniper if the roof becomes a sealed drum. To the untrained eye, the difference between a hut that drips at midnight and one that stays dry is invisible until the vents open and the air begins to move as if by kindness, but the charts insisted that kindness had numbers behind it and louvers were the instruments that played them. One by one, the objections that began the project fell. Wait, because 4 men could lift a panel, time, because 10 could raise a shelter by dusk, rot, because no wood met the ground, corrosion, because galvanizing in paint slowed the ocean's hunger, suffocation, because vents and louvers turned a box into a lung. If a philosophy can be embodied in a crate, this one said: roof first, air always, anchors before comfort, and let the rest be a problem for a day when men are no longer coughing themselves awake in the dark. The last test before the green light was not a wind or a weight but a rehearsal with a new crew handed a manual and a clock, and they finished, with mistakes they could fix and sweat they could spare, before the hour the engineers feared, which is to say they finished before doubt could gather. Approval did not arrive as a parade but as a purchase order and a schedule, a promise that the work would now count in thousands and that the steel which had learned to flex in a Rhode Island squall would soon learn to endure on coral and jungle. Production would refine the kit, but the tests had settled the nature of the thing: an arch that behaves like a bridge, a shell that breathes like a lung, and an anchoring system that treats the ground as a partner rather than a pedestal, a trinity that turns weather from an enemy into an opponent. With that, the warehouse stopped being a proving ground and became a starting line, the place from which 1,000 roofs would sprint into storms and sleep, carrying with them the discipline that had made a few prototypes into a field-validated answer for a war fought as much against climate as against men. When the order came to ship, it landed not as relief but as responsibility, because every intact night under a dry curve would be a victory multiplied by engines that start at dawn and radios that speak clearly at noon, the quiet triumphs that string together into a campaign. The green light, then, was not the end of testing but the beginning of proof, the moment when weather would grade without pity and crews would discover that the kit had been designed not just to resist wind and water but to forgive haste and fatigue, an ally, not just a shelter. And as the first train clattered west with crates marked for distant beaches, the engineers allowed themselves one private certainty: the next storm would still be hard, but not hard enough to unteach what the curve and the air and the anchors had learned together. They turned blast furnaces and rolling mills into a cadence for war, retooling presses to bite corrugations into sheet steel and booking galvanizing baths so zinc could armor every panel against the ocean's appetite before a single crate left the factory floor. In Detroit and the Midwest, Strand Steel and allied shops shifted from peacetime framing systems to light, repeatable members and skins that could be stamped by the thousands, proving that simplicity in the field demanded complexity, and discipline, in the plant. Crating became an obsession as real as any blueprint. Panels were nested, ribs stacked, and end walls bundled in the exact order of assembly so that a kit unpacked like a sentence that tired hands could read by touch. Where the first-tier rib huts had shipped in a crowd of crates, refinements cut volume and weight until a single hut could ride in a lean stack, an efficiency that multiplied across rail yards and piers like interest on a debt paid in time. Every pound removed in the factory vanished twice from the battlefield, once on the dock and again on the beach, so designers trimmed where it counted and let the arch do the work steel thickness used to do. From mills and fabricators, kits rode rails west in a choreography as deliberate as any assembly, meeting cargo schedules that pushed them into the holds of Liberty ships built to move essentials faster than war could consume them. Liberty ships were not elegant but they were abundant, and their standardization meshed with the huts, crates sized for quick stow, parts documented so that a manifest read like a diagram, speed the only virtue that mattered more than capacity. On the docks, Seabees and stevedores learned the kit's language in reverse, loading by the very sequence crews would need on the far shore, because a misplaced box in San Francisco becomes an hour lost on an island with rain on the way. Numbers began to move the way weather moves, orders in the thousands per month, versions refined midstream without breaking the rhythm, and a total wartime output that climbed past 150,000 huts as the curve took its place beside the Jeep and the Liberty ship as a signature of scale. Galvanized corrugations gave the huts their humble, enduring face, a texture that turned wind into harmless eddies and salt air into a slower enemy, buying months and years where untreated steel would have failed in weeks. At Quonset Point and beyond, production shifted through generations, T-rib to redesign to strand steel, each iteration shaving weight, simplifying steps, and aligning dimensions with rails and hulls so the system traveled as efficiently as it stood. In the manuals, the factory's invisible care revealed itself in the field as ease, common fastener sizes, interchangeable panels, and instructions drawn for eyes half blinded by glare and fatigue. The creed on the beach was as clear as it had been in the warehouse: no welding, no concrete, no specialists, just wrenches, a clock, and a crew that could become a team inside an hour. 10 men could raise the standard hut in a single day with hand tools, and with strand steel refinements a practiced crew could do it faster with fewer people, the payoff for every hidden decision made upstream. Assembly was a dance that began with end walls to tame the wind, arched ribs or panels to find the curve, skins to close the weather, and anchors to teach the hut the ground's language before doors and louvers gave it breath. The supply chain did not end at the surf. Spare fasteners, duplicate diagrams, and corrosion coatings arrived with the kit, acknowledging that perfection dies quickly in salt and sun unless maintenance is made as simple as fastening a buckle. Where climate demanded it, liners and insulation rode along to soften heat and noise and to keep moist air from condensing on cold steel, a comfort that was also a medicine against the damp illnesses that stalked the tropics. Factories learned to build for climates they would never see, louvers and ridge vents for islands that breathed like jungles, stiffer end walls and closures for northern gusts, and utility spans for depots where engines and crates, not cots, filled the floor. Each crate sent was a promise kept twice, first to the logistics officers who measured victory in tonnage per day, and second to the crews who measured it in roofs per dusk, and the alignment between those measures was the quiet miracle of the program. In reports and photographs that crossed desks back home, the huts repeated like a refrain at airstrips, hospitals, and messes, proof that a standardized kit could generate a civilization at speed wherever ships could land and a crew could lift. Production did not pause to admire itself, it listened, folding field complaints into design memos that altered flanges, gaskets, and anchors without halting the line, an industrial tempo that treated feedback like fuel. The arch's strength traveled well because it resided in shape rather than in mass, letting a lighter kit survive heavier weather so long as anchoring and sequence were honored like sacred steps. Crates marked for Alaska and the tropics left the same platforms within the same hour, a testament to a system that could wear many climates without changing its bones, only its clothing. For logisticians, the arithmetic was irresistible: more shelter per ton, more function per crate, more speed per crew hour, an equation that freed carpenters and concrete for the rare places that needed them most. For the men sleeping under them, the arithmetic reduced to human terms: a dry night after weeks of rain, a radio that stayed clear after noon storms, a morning where engines started because hands were steady. The war had demanded a building that behaved like a product, and industry answered with a product that behaved like a building, one whose parts could be counted in a rail yard and whose value could be counted at reveille. If there was a single image that captured the transformation, it was a Liberty ship's hold packed with nested arcs and numbered bundles, a cargo of curves headed toward beaches that would turn them, by evening, into rooms full of breath and light. In that flow, mill to rail, rail to pier, pier to ship, ship to surf, surf to shelter, the hut became more than steel, it became a logistics language every service branch could speak fluently before the year was out. And as monthly counts rose and theaters multiplied, the curve that began as an answer to rain and rot became an emblem of a nation's capacity to mass-produce not just weapons, but the quiet conditions in which courage can do its work. On Guadalcanal, where Henderson Field was repaired between shellings and air raids, the Seabees learned to raise roofs as fast as they patched runways, turning crates into shelter under artillery glare so that food, tools, and nerves could survive the night. The arch earned its keep when blast waves rolled across the camps, where flat planes tore and frames racked, the curve flexed and returned, a behavior already seen in bombed Nissen sites and now repeated in the Pacific with a different enemy and the same physics. By the time the 73rd Seabees were erecting hut lines for field operations at Munda, the sequence had become muscle memory: end walls to face the wind, arches to find strength, skins to close weather, so even under sporadic fire the day ended with light and breath inside steel. Anchors mattered as much as courage. Crews staked, wired, and skirted the bases with sandbags and earth, borrowing tricks from northern outposts where Marines had already learned to tie down tin roofs with barbed wire and wrap huts in peat to blunt shrapnel and cold. In volcanic sands further north and west, Seabees who could drive a crane under fire could also read ground like a map, cutting trenches, building berms, and siting bivouacs so that wind had less to grip and rain had somewhere to go before it turned camp into swamp. Cold taught a different cruelty in the Atlantic stations, where Seabees first cut their teeth in Iceland, Newfoundland, and Greenland, and the huts wore vestibules, baffles, and sawed skirts so that gales lost bite and interiors kept their heat long enough for hands to steady. Photographs from winter lines of curved huts show sandbags and turf hillied against steel and improvised windbreak vestibules at the doors, a field grammar that migrated with crews and was copied wherever weather argued with metal. When Typhoon Cobra tore into the Third Fleet with sustained winds near 100 miles per hour and gusts far higher, it was a naval catastrophe that rewrote weather doctrine overnight, and ashore it stiffened the manual's blunt insistence on anchoring as a life-or-death step, not a suggestion. The storm's lesson traveled with dispatches and diagrams: predict, seek shelter, respect loads, and the hut literature answered in kind with pages on stake patterns, cable tension, and soil-specific anchoring that turned invisible forces into pictures a tired crew could obey. On islands where the ground was coral crust over sponge, crews added timber sleepers to spread load and pin base plates deep, while in loam they chose shorter stakes at closer intervals, the kind of field nuance that manuals captured so the next crew did not have to guess. At Guadalcanal, the proof of concept appeared in the small mercies of routine: a chow line filing into a curved officer's mess, steam rising into louvers instead of into lungs, and a sense that a camp could outlast the weather long enough to fight on schedule. Elsewhere, huts adapted their jobs without ceremony: surgical wards with extra openings cut for light and airflow, radio rooms with liners to quiet the drum of rain, and depots where the 20x48 workhorse swallowed crates and tools with room to spare. Field notes returned like homing birds: reinforce end walls in gale alleys, keep spare fasteners oiled against salt, extend shallow overhangs to shield louvers, and never skimp on the first hour of anchoring when the horizon looks bruised. Bomb fragments could maul a skin without stealing the arch, and crews learned to patch corrugations the way they patched runways, a rhythm of damage and repair that favored structures distributing loads instead of hoarding them in beams that failed all at once. In jungle heat, a hut that breathed was the difference between a clinic and a feverdrome, so ridge vents and end louvers stayed open unless rain slanted hard enough to demand baffles, a balance that medics credited with fewer coughs and clearer morning heads. At night, condensation, the enemy with perfect attendance, was beaten back by airflow and liners that kept moist air from finding cold steel, shrinking the midnight, indoor rain to a few stubborn drips that a morning towel could handle. On the line, no one praised geometry with words: they praised it with sleep, with engines that started, and with radios that did not drown in humidity by noon, the quiet dividends of a curve that turned weather into a manageable problem. When gales came, properly anchored huts shuddered like living things and held, while the ones with hurried tie-downs skated or twisted, a cruel but consistent verdict that drove home the mantra: strength is shape, survival is anchors. The arch did not make men invincible, but it made them less fragile, and in a war where supply lines were as thin as the horizon, that margin, the night's rest, the dry cot, the sheltered table, became a weapon as real as anything on a rack. In every theater the huts kept acquiring local accents, extra bracing here, sawed skirts there, vestibules and wind baffles where gusts knifed through ranks, none of it pretty, all of it effective, a folk architecture of survival written by the people who needed it. Commanders noticed that repair lists shortened where anchoring checklists were treated like orders, and that morale sharpened where interiors stayed breathable. The pattern was so plain that even skeptics stopped asking for wood barracks they could neither staff nor protect. Seabees carried the gospel from beach to beach, end walls first, anchors early, louvers open, spares at hand, and never trust a sky that promises calm, because the only calm that counts is the one created under a curve. In this way the hut ceased to be an object and became a practice, a way of moving through weather and war that let thousands of small shelters behave like one large, reliable promise wherever they landed. If resilience had a formula, it was simple enough to teach to anyone who could lift: geometry plus preparation, vent plus anchor, curve plus care, an arithmetic of survival that paid off in hours of dry, breathable time. The photographs that came home rarely showed the wind, only the aftermath: arches still standing behind men in line, louvers half open, sandbags slumped and honest, proof that sometimes the most important victories are too quiet for a headline. And the men inside, who learned to trust a shape as much as a plan, carried the lesson forward: nothing about this is magic, but everything about it is mercy earned by doing simple things exactly right before the weather arrives. The war ended with a shortage that statistics could not soften. Millions of veterans came home to cities that had grown without them, and roofs were suddenly more precious than victories, which is how a battlefield shape crossed into domestic life as surplus Quonset huts were declared available for the rush to house families fast. The War Assets Administration turned naval depots and airfields into marketplaces, and on the piers at Port Hueneme veterans lined up to claim the same corrugated arcs that had once stood against salt and shell, now priced as a bridge between service and a front door. Photographs from that summer show men in work shirts and service caps in a fenced lot among stacked ribs and panels, proof that the kit had become a civilian rite of passage, its promise as much about dignity as shelter. In Los Angeles, the scale was civic and immediate. Roger Young Village rose on the old Griffith Park Aerodrome in roughly 2 months, 750 Quonset huts partitioned into duplexes for 1,500 families, more than 5,000 souls at its height, a temporary city with curved shoulders. Newspaper copy called it a village, but it was also a blueprint for speed, its streets named and its services improvised in steel: beauty parlor, branch post office, clinic, school, and market, all housed in arcs that had learned to be anything. When the village was dedicated in April 1946, it felt less like a ribbon cutting than like a truce with scarcity, a pact to make do together for as long as it took the permanent boom to catch up to the temporary crunch. The huts had traveled well from Port Hueneme, just up the coast, where late-model units were disassembled and hauled inland at a cost that could be counted with a pencil even as the value was measured in bedtime and breakfasts. Across the country other cities tried variations on the theme. Brooklyn and Queens cited clusters for returning GIs and young families, threadbare neighborhoods knit by steel curves and mutual aid, while brick and timber caught their breath. College campuses, flooded by the GI Bill's tidal wave of enrollment, sprouted hut villages and classroom rows, the geometry of war becoming the architecture of opportunity for veterans now trading rifles for textbooks. In these ad hoc academies, lectures echoed off Masonite liners and rain drummed a steady beat on galvanization, and yet the point was not the poetry, it was the fact that learning could expand at the same pace as arrival. Farm country took to the curve with the pragmatism of those who prize utility over signatures, converting surplus huts into hay barns, milking sheds, machine shops, and storage, because clear spans and fast roofs do not belong to any one class of labor. Churches and Sunday schools borrowed the same economy, gathering under arches that had known alarms and now held hymns and lessons, a reuse so natural that parish minutes barely noted the origin story. Manufacturers saw a market beyond surplus, and Steel appointed dealers nationwide, issuing press notices that boasted 257 adaptations and inviting towns to think of the hut less as a container and more as a kit for solving local problems. Municipalities, cautious but practical, wrote permit advice that insisted on upgrades, solid foundations, larger window areas, permanent plumbing, and braced partitions, because if the hut was to be a house, it would wear a few domestic manners. Contractors and owners tacked false fronts onto main streets to hide the curve from an eye that preferred rectangles, cladding end walls in brick or siding while the arch carried on behind the disguise unfazed. Some huts went up on new slabs and gained porches, window boxes, and little lawns, the ordinary gestures by which a temporary shelter learns to answer to a name, even as everyone knew the long plan pointed elsewhere. Not every adaptation charmed its occupants. The slope of the sidewalls stole headroom from closets and cribs, and the 20 by 48 footprint, 960 square feet, could feel more like a tent with dignity than a home with expansion joints. Veterans sometimes bristled at waking under a shape that looked like the one they had left behind, a reminder that even good tools carry memories, and that memory can weigh more than steel. Meanwhile, Levittows and their kin multiplied with ranches and Cape Cods on slabs, the price of permanence falling enough to draw families out of the curve and into straight lines with lawns that were rules as much as grass. By the mid-1950s, Roger Young Village was dismantled to make room for the Los Angeles Zoo, its huts sold off and trucked away, the city shedding one skin for another as its post-war self took form. The end was not an erasure. The huts moved on to small businesses and outbuildings, to garages and repair shops, to county yards and reclamation projects, because the habit of reuse finds work for anything that can still stand. Elsewhere, agencies like the Bureau of Reclamation and state highway departments filled their own shortages with arcs turned into offices and shops, a bureaucratic ingenuity that made budgets go further than schedules allowed. In photographs from the era, the curve keeps reappearing in unexpected places, behind signage on a car lot, tucked beside a new brick school, in a farmyard half buried in hay, always patient, always useful. When veterans bought huts straight from depots, they discovered the same logistics that had once favored the Navy, crate weights, rail tariffs, and the math that made a group purchase cheaper per £100 if friends pooled their plans. City permit counters answered with lists and measurements, insisting that if a hut would house a child it must also admit more light, more plumbing, and more bracing, a small bureaucracy of care that domesticated the military kit. Even as the market cooled, the form persisted wherever speed, cost, and clear span mattered more than fashion, which is why barns, depots, and repair shops kept choosing the arch long after people rooms moved on. Preservationists later called attention to the problem of invisibility, that many huts were still there but masked, false fronts hiding a heritage of improvisation in favor of streetscapes that preferred a different story. The irony is gentle but clear. A building born to be seen as a kit became valuable partly because it could vanish behind other clothes, performing without demanding applause. In Guam and across the Pacific, the post-war gallery shows arcs alongside Quonset-derived stores and offices, evidence that in places closer to their origin the hut simply stayed and worked until the next thing came along. Some universities kept their hut villages longer than planned as enrollments surged again, repainting, replumbing, and renumbering until the curve was as familiar as a mascot, its utility outlasting the first intention by a decade. What began as emergency architecture matured into a vernacular, a way of answering, now, with steel and bolts and breath, and the measure of its success is not how many survive intact but how many lives pass through their shade in the brief years when each arc meant a door. If the war taught the arch to stand, the peace taught it to belong, if only for a while, and that while was enough to bridge a national gap between need and norm with a shape that understood how to be many things in one body. Even as fashion moved on, the curve left fingerprints on the American landscape, a memory of a time when a country chose speed and sufficiency over finish and discovered that mercy can be flat-packed and numbered. 2. The same logic that once turned beaches into bases now turns crisis into shelter, as humanitarian agencies ship flat-pack units that assemble fast, breathe better, and protect dignity, an echo of the wartime creed that a building must be a product first and a place second. UNHCR's refugee housing unit, developed with better shelter and backed by the IKEA Foundation, arrives as a kit with a lightweight steel frame, rigid roof and wall panels, integrated floor covering, a solar lamp with charger, and an anchoring system designed for rough ground and rough weather. Field pilots in Iraq and Ethiopia refined the prototypes into a production model in 2015, and initial deployments rose into the tens of thousands, demonstrating that quick assembly by non-specialists and reproducible ventilation are as life-saving as the roof itself. The unit's 3-year design life and 17.5 square meter footprint are not luxuries but a calculus of shipping volume and human space, proving again that logistics is a synonym for mercy when the brief is shelter now. Where the wartime arch taught weather to flow, today's humanitarian kits teach supply chains to breathe, panels nest for volume, fasteners standardize for speed, and pictorial manuals minimize language barriers for crews that may be meeting one another on site for the first time. The continuity is not cosmetic, the same trifecta, flat pack, unskilled assembly, and climate-aware ventilation, remains unbeatable when urgency, distance, and fatigue set the rules for what good means on the ground. If the war proved that shape can deflect force, contemporary research proves that roof geometry still dictates survival, with hip roofs consistently experiencing smaller wind pressures and better performance than gables in hurricane regions. Full-scale studies and post-storm investigations by IBHS and partners show how roof edges and geometry govern uplift and unsealing, translating aerodynamic theory into fastening schedules and detailing that keep roofs attached when gusts become weapons. The lesson, once learned by an arch in a gale, now appears in codes, insurance discounts, and mitigation roadmaps that reward simpler, less turbulent roof forms because they fight wind with physics rather than with thickness alone. Under the same banner of quick, durable, and forgiving, modern Quonset-style homes have migrated from military surplus to design choice, using clear-span steel arches to create open interiors that can be built fast, customized deeply, and maintained lightly. Guides and case studies document how 2-foot modular arch panels scale a home from tiny to expansive, how interior frames add mezzanines without interrupting the shell, and how galvalume or galvanized skins trade ornament for a long life in harsh climates. DIY culture has embraced the curve because the kit's grammar remains legible: brace the first arch, repeat the rhythm, close the shell, and then tune openings. An assembly line a small crew can perform without welding, just as earlier crews did under worse skies. Vendors tout wind and snow performance as an inherent benefit of the continuous arch, but beneath the sales pitch is the same principle that once saved nights in the Pacific: distribute load along a curve, eliminate weak corners, and let fasteners act in chorus rather than as heroes. In disaster recovery and displacement, better kits now come with light and charging out of the box, acknowledging that a phone call and a lamp can be as stabilizing as a door, and that safety includes communication and the absence of darkness. UNHCR's catalog treats ventilation and anchoring as first-class citizens, with illustrated sequences for hot, cold, windy, or wet conditions, turning invisible forces into simple steps that crews can follow without debate. The humanitarian sector's pivot to participatory design, soliciting feedback from families and pilots, iterating models before mass deployment, mirrors the wartime habit of learning from field failure faster than failure can spread. What looks like modest technology, louvers, ridge vents, standardized bolts, is in fact refined empathy for lungs and hands, because the kit honors the reality that a shelter that cannot breathe or be repaired quickly is a liability disguised as a gift. Meanwhile, Building science roadmaps have made the physics of wind accessible to homeowners and builders, linking simplified roof forms and edge detailing to real reductions in losses, a domestic echo of lessons once hammered into manuals for hurried crews. Architects and self-builders reinterpret the arch for aesthetics, a mountain lodge here, a minimalist studio there, but the underlying reason persists, a clear span envelope that ships rationally, assembles quickly, and resists weather without needing a cathedral of scaffolding. Tiny house culture borrows the kit's confidence, compressing square footage while preserving height and air, and leaning on steel's fire resistance and low maintenance where off-grid life demands reliability over flourish. In luxury brackets the curve is dressed in glass and timber, but the skeleton keeps doing the old work, shedding wind, spanning cheaply, and turning a small crew with hand tools into a construction force multiplier. Even as materials evolve, composites, better coatings, integrated photovoltaics, the choreography remains familiar, crate to ground to shelter in hours, not weeks, because speed heals, and a dry room can turn fear into routine. The paradox endures, simplicity is expensive to design and inexpensive to trust, which is why the best modern kits are spare in pieces and rich in diagrams, saving thought where fatigue will be most merciless. From refugee camps to coastal rebuilds to backcountry homesteads, the old triad has not changed, shape that forgives, logistics that scale, and instructions that teach a crew while they work, an inheritance as practical as a wrench. The 1940s solution keeps solving 21st century problems because scarcity and urgency obey the same arithmetic, and the curve keeps offering the same answer: move the wind, move the air, move the work into the kit, and let people move in by nightfall. Today's battle rhythm still demands roofs that can arrive in pieces and become protection by nightfall, and the lineage from the wartime arch lives on in modern, rapidly deployable systems that treat shelter as logistics-first engineering rather than as carpentry under fire. On the soft-walled side, drash shelters from HDT global scale from small man-portable units to large, interconnected mission facilities, carrying the same promise as the old kits: fast setup, standardized components, and field-reparable parts under punishing conditions. The Drash M series is built to be mobile, lightweight, and user-friendly at squad scale, expanding quickly into livable space without heavy equipment or specialized trades. At the other end of the family, the Drash J series deploys an entire 1,250 square feet facility from its own trailer in under 40 minutes using a low-pressure air bladder, operable from -50 degrees Fahrenheit to 131 degrees Fahrenheit, then networks to other units as a modular, quick-build campus. Procurement pipelines reflect this shift toward ready-to-ship protection, with the Defense Logistics Agency cataloging commercial tactical shelter systems, HDT/Drash among them, alongside legacy mil-spec tents so commanders can buy speed in a standard package. Western Shelter, born in wildfire camps and hardened by disasters and deployments, now fields a portfolio for FEMA and DoD missions that emphasizes rapid deployment, durability, and turnkey support, from logistics planning to on-site assembly. The company's shelter lineup ranges from framed systems to fast airframe models like the Sentry and Sentinel, both designed to go up with minimal manpower and to reconfigure on the fly as command posts, clinics, or billets. Where large clear spans are needed without pouring foundations, container roof kits arch between ISO containers to form instant depots and work bays, repurposing shipping geometry into shelter the way earlier crews turned railcars into huts. Under the hood, modern guidance folds hazards beyond wind and rain into design, with FEMA 453 outlining blast-aware detailing for shelters and safe rooms so that fast-erect structures handle overpressure and fragmentation without behaving like brittle frames. The physics that once favored a smooth curve against gusts and shrapnel still apply, reminding planners that survivability is as much about form and anchoring as it is about thickness or material pedigree. What these systems sell, at bottom, is time, the conversion of crates and pallets into climate and security within hours, so that operations begin on schedule and fatigue does not have the first move. Their economies are counted less in square feet than in roof hours delivered per crew hour spent, a calculus that aligns procurement, logistics, and morale the way the best wartime kits once did. This is not nostalgia, it is continuity, visible in standardized fasteners, pictorial manuals, and deployment sequences that assume the crew has been awake too long and has too little margin for misunderstanding. From combat outposts to hurricane response, the through line is the same: fold complexity into the kit so the field is left with decisions about sighting and anchoring, not about whether the parts make sense. Beyond Earth, the lineage bends toward new materials but keeps the old logic, as NASA's 3D printed habitat challenge formalized the problem of shipping minimal mass and printing maximal shelter under alien weather and radiation. The CHAPEA program's Mars Dune Alpha, a high-fidelity analog habitat at Johnson Space Center, uses construction-scale 3D printing to simulate a surface outpost, with an arching shell and varied volumes to reduce monotony and support long-duration crews. ICON's printed shell demonstrates why off-world building returns to curves: continuous surfaces distribute loads, simplify sealing, and accept add-on shielding without the weak corners of rectilinear frames. In parallel, Mars City Design's Alpha Concepts explored aerodynamic shells tuned to carry regolith as a radiation blanket, explicitly shaping the exterior to control how sand loads settle and how wind scours rather than scours away. The point is not that a Quonset will land on Mars, but that the same three imperatives: ship well, assemble quickly, and let shape do work, govern have design when resupply is rare and the weather does not care about intentions. Just as island huts learn to breathe to stop midnight rain inside, space analogs choreograph air, light, and acoustics to protect circadian rhythm and cognition, because a shelter that keeps people whole is more than a seal against vacuum. Back on Earth, rapid deploy systems continue to hybridize: framed and inflatable sections, containerized power and climate modules, and roof geometries chosen for aero performance first, quieting uplift and debris impacts by shaping flow rather than fighting it with mass alone. Procurement pages that once listed tent sizes now list systems: shelter plus power plus environmental control, acknowledging that the mission begins when the microinfrastructure arrives as a kit and not as a wish. When helicopter lift or pallet constraints dictate form, designers answer with shelters that tilt out of trailers, inflate their frames, and lock into service in under an hour, prioritizing repeatable choreography over one-off cleverness. Some of these are destined for austere runways, others for wildfire base camps or triage corridors, but all inherit the same ethic: a good shelter is a verb that begins at the crate and ends only when interior air and anchors are proven. If budgets demand justification, it comes in the old arithmetic: fewer hours to shade a medic's hands, more hours of clear comms after the storm, and less breakage in transit because the kit was designed backward from the hold to the hand. The frontier work in 3D printed shells and regolith cover is, in a sense, a high-gravity version of the same answer, replacing fasteners with layers and corrugated steel with printed composites, but still treating the curve as the way to reconcile stress, seal, and speed. In both disaster zones and analog habitats, the decisive advantage is not any single material but the system's humility: assume fatigue, honor logistics, make the instructions teach while the hands move, and let geometry forgive small mistakes. The brief that began with rain, rot, and wind on coral atolls has become a general rule for building under pressure: when the mission is speed, strength, and simplicity, design the supply chain as carefully as the shell and let the curve carry more than its own weight. From beaches to backlots to simulated Mars, the through line is unbroken: move the wind, move the air, move the work into the kit, and by nightfall a room exists where only intention stood that morning.